4. It's officially properties of logarithmic equations. However, if you recall, we just learned some properties in 3.3, yes? So I don't remember what 3.3 was called. But basically, I feel like we're adding on to their properties. Okay, so we had those, 4 basic properties in lesson 3.3. We're kind of adding on. These are, some other properties. These are the properties that are going to be really come in handy when we work to solve equations. Okay, so 4 properties to talk about and demonstrate a little bit. We have the product rule. Okay, now the product rule basically says if you have a product inside a log, so there's multiplication inside a log, that singular log can be split up into 2 logs that are now being added. Okay, obviously keeping the base the same, but the idea of log base b of r times s can basically become log of r plus log of s, still keeping it base b. Okay, so that is our product rule. A product within a log can become 2 logs being added. Quotient rule works similarly. Quotient rule says if there is division within a log, then that's going to change to the subtraction of 2 logs. And so log base b of r divided by s becomes log base b of r minus log base b of s. So keeping the base, of course, the same always. Obviously, notice it's going to be numerator minus denominator. So log of r minus log of s. Okay. We have the power rule. The power rule says if you have something such as log base b of r to the c, that c value, that exponent or that power, can move out front. Okay, so that c there becomes this c here. And again, it's a useful tool when we're solving equations, is to be able to take that power and move it out front. Okay, those top 3 are the ones that we will use to solve equations. And guess what lesson 3.5 is? Solving equations. Okay, so now this third one, change of base rule. Okay, this is the one that allows you to do a log of any base on any calculator. Okay, so the idea here for the change of base rule, log base b of r. Well, depending on what base that is, depends if you have a calculator button, right? The only, typical calculators have a log button, which is log base what? 10. Or a natural log button, which is log base
2 point,
or in other words, e, right? Okay, past that, majority of calculators aren't going to be able to do logs unless it's one of those 2 bases. Change of base formula allows it to change it to a base we could use a calculator button for. So log base b of r. You could go to natural log, or you could go to log base 10. Technically, you can go to any log, but you're going to want to go to a log that you have a calculator button for. And we'll demonstrate this here. But natural log of the inside divided by natural log of the base. Or log base 10 of the inside divided by log base 10 of the base. So it's basically doing r divided by b in logs. Okay? So that is change of base rule. We don't see that a whole lot in equations. Not saying we couldn't, but it's more of just, I don't have a calculator button for that. How can I find it? Okay? So, in example 1, we have 1, 2, 3. We're going to either expand, like in 1 and 2, we're going to take a singular log statement and expand it. So using things like product, quotient, power rule, and expanding this into multiple individual logs. When we get down to example 3, we're going to do the opposite. We're going to take those, 3 logs there, and we're going to condense that and write it as 1 log. Okay? Ready to try it out? Okay, so expanding this log of 8xy to the 4th. Thoughts on where to begin? As in, pick one of the rules from above.
Product.
Okay, how can I use the product rule?
Would it be like log of 8x plus the log of y below.
Almost. Split it a little bit more.
So you split the 8 and the x.
Oh, we do it in 3.
Mm-hmm. 8xy to the 4th is technically 8 times x times y to the 4th, correct? Okay. So we are going to split into 3 logs. Now, yes, you could just split into 2 logs like originally suggested. However, that's not going to get you to the final answer. So, I'm going to start by writing this as log of 8 plus log of x plus log of y to the 4th. So that is my product rule there. Okay? What else?
Can you put the 4 at the beginning of the log?
Okay. So, we have a power here, yes? What's our power rule say we can do to the 4? You can move it out front of this log. Now, 2 things to talk about before I write down an answer, because I'm not quite ready to write down an answer. First of all, why did we use the product rule before the power rule? Because we had to use the product rule first. But that power, was that power on everything?
No.
It was only on the y. So we had to wait until we had the y term by itself. So yes, we had to use the product rule first in this scenario before we could get to the power rule. Hopefully I'm saying my words right there. Now, technically, we can use the power rule on one other term here.
Would be x.
I mean, you can.
Can you turn the 8 into 2 cubed?
What do we know about 8? Is 8 indeed the same as saying 2 to the 3rd? Okay, now, logs like to simplify the powers. Okay? It would be very normal to see an answer key go down and make this a log of 2 to the 3rd. Because now, what can I do?
Or 3 on front.
We can move that power of 3 out front, yes? Okay. Okay, now, I'll tell you up front. I'm not 100%, oh my gosh, that's horribly wrong if you don't. Okay? But I encourage you to try and look for those powers. So if I write this out now, I'm going to move the 3 out front there. So it's 3 times log 2 plus log of x plus, I'm going to move my 4 out front, so it's 4 log of y. Okay? My other options were a quotient rule, which I had no quotients, and as I said, change of base rule doesn't really have a play in what we're doing here for the most part. Okay? So, this would be your expanded version. Questions there?
Can you add the 3 and the 4? Like, if you, well, I guess we don't minus. Never mind.
Can we add the 3 and the 4? Why am I going to say no?
Because the y.
It doesn't-
Are my logs like terms?
No.
If these were like logs, it'd be a different story.
But like
we can
logs,
talk
I mean,
about
like if they're both log 2 or
Yes.
log y. Okay.
Okay. Okay. Good?
Yep.
Okay. Example 2 is another expand.
Oh, sure.
I agree. How does quotient rule work here?
Would be like the natural log of the square root of x squared plus 5 minus the natural log of x.
Okay. So division within a log can be split into 2 logs being subtracted, numerator minus denominator. Okay. Notice, by the way, last time it was log. I didn't write a base in my logs last time because It was just log base 10. I just kept the log base the same. Here it's natural log. So what are we using this time? Natural log, obviously. So we're going to do natural log of square root of x squared plus 5 minus natural log of x. Okay? Now what?
You get rid of the square root.
I don't know what you mean by get rid of the square root, so I'm not sure how to answer that.
Like, can you square both sides? Or
This is not an equation, so I can't just magically decide I want to square both sides, because if I do anything like that and add anything in like that, I'm changing the value of this expression. When it's an equation, you have a left and a right side. You can do things like that. But when it's just an expression, I have to veto.
So technically, because the square root is that an exponent of 1 half.
Yeah, so that's why when you said, can we get rid of the square root? I'm like, well, maybe. A square root, let me rewrite this, is a power of 1 half. True statement?
Yeah.
We talked about this last week. So x squared plus 5 to the 1 half. Now what do you see? Yeah. Now that we've gone from a square root to a power, can we use our power rule? Yeah. So that 1 half can go out front, and this can become 1 half natural log of x squared plus 5 minus natural log of x. Okay. Anything else? Now, I am indeed boxing it, which you guys know me. That means I'm done. Okay. For those of you out there that were all ready to break this into natural log of x squared plus natural log of 5, why can I not do that? Okay, it's one term. We have a product rule, yes? The product rule says if there's multiplication within a log, it becomes 2 logs being added. Does that say anything about addition within the log? Addition within the log stays as is, you're stuck. Okay, so addition within the log does not separate into anything else. It just stays as one log. You can't do anything with that, okay? Okay. Condense. Condense means shove it all together appropriately. Okay? So, 5 natural log of x minus 2 natural log of xy plus 3 natural log of y. Okay, so we're kind of reversing the order of what we've been doing, yes? Okay, so we're going to take the 5 and make it a power. We're going to take the 2 and make it a power. We're going to take the 3 and make it a power. Okay, so I'm going to write this out. It's natural log of x to the 5th minus natural log of quantity xy to the 2nd plus natural log of y cubed. Okay, so kind of like the last two, we used the power rule at the end. Now we use the power rule first. Okay.
Do you want to do the product rule?
For what?
Natural log of xy squared plus natural log of y cubed.
Not exactly.
The quotient rule, which is
For which terms?
natural log of x to the 5th minus natural log of xy squared.
Okay. Could we do the quotient rule between those first two terms?
Yeah.
Yes. Okay. Now, why did I veto the product rule between those last two terms? This guy has a negative out front. If something's being subtracted, it's going to have to be part of a quotient rule. Okay? In order to do a product rule, it's going to have to be a positive and a positive. Okay? Now, and here's what I'm going to argue. There's a couple of different orders we can do this in, yes? Before we decide how we want to proceed, we're going to talk about that. So, one option, these first two are being subtracted, yes? If we do those first, and whichever, we're going to have what? X to the fifth over the xy squared. What are we still going to have hanging out here? Another term being added. So what are we going to have to use then? The product rule, yes? Now, I don't know if there's no right or wrong way to teach this that well. There are wrong ways to teach this, but there's not just one right way to teach this. I'm going to suggest, just because it'll be mathematically cleaner, okay? I'm all about keeping things clean. What if I reorder my terms and put my two pluses first and my subtraction at the end? Okay? And this, again, is not the only way to do this, but my reasoning is it's going to be a little cleaner. So before I proceed, I'm going to flip-flop these second two terms. So I'm going to keep it as natural log of x to the fifth, but then I'm going to make it plus natural log of y cubed, and then minus natural log of xy squared. As I said, I'm not saying you could do this a different way and still work out the same in the end. My reasoning, though, is I feel like it's going to be a little cleaner if we use our product rule first and then just have one quotient rule at the end. Okay? So what can I use the product rule on now? I can use the product rule on those first two, yes? So if I do that, this becomes what? Natural log of x to the fifth, y to the third. Because two logs being added can be rewritten as one log, where the insides are multiplying. And we still have minus natural log of xy quantity squared. If you haven't figured out, no, I'm not done yet. We're going to use the second column. Okay. And again, not the only way to do that. Okay, that's not what I'm saying at all. Now what? Yeah, and I just think it's easier when you just have two specific things being subtracted. You don't have extra stuff hanging around that we do this. So now, how are we going to write this? Not equals.
Oh, natural log, parenthesis, like x to the fifth, y cubed on top, divided by x, and parentheses, xy squared.
Okay, that's one way to do it.
Wait, because the 2 applies to both the x and the y, could you subtract it then? So there'd be x to the third and then y to the first.
Okay, hold that thought. Okay, x to the fifth, hold that thought. We're coming back there. Okay. On top is x to the fifth, y to the third, yes? Now on bottom, we have two different ways to write this. I was going to kind of skip a step here. One option is on the bottom, you could put xy quantity squared, yes? However, the first part of what Thomas said, what do we know about xy quantity squared? It goes with both. So how could I rewrite xy quantity squared? So I'm going to write this as x squared, y squared. Are we okay with that? So, and I'm doing that in preparation for where we're headed next. Okay? I just didn't want to do too many steps at once or I'm going to lose people. Some of you got it and you see it going in your heads, great. But in case anyone doesn't, I can't do that all in one step. Now, officially, are we done using our rules from up above? Yeah, we used all of them, didn't we? I mean, not change of base, but we used all three I expected to use. We used the power property, we used the product property, we used the quotient property. Now, it just comes back to basic algebra rules. What do we know about basic algebra rules?
fifth minus x squared equals x cubed.
Mm-hmm.
And y cubed minus y squared is y.
So when you divide x to the fifth divided by x to the second, you keep the base of x the same, and the shortcut is to subtract the exponents, right?
Yeah.
So this becomes natural log of x to the third, y to the first, or in other words, just y. Okay. You'll notice, I don't think I addressed it, I've been using a lot of parentheses on this problem. Debatable whether it's required because it is all one term, but I think it's good practice. Now, when we had the x squared plus 5, those parentheses were required because otherwise the plus 5 looks like it doesn't go with the log. These, some people would argue, oh, it's all one piece, but I think it's just smart to use the parentheses there. Okay, questions on this? Okay. Ready for example 2 then? And by the way, I will say a lot of homework is doing this type of stuff. Okay, so I know the question was like 1 through 28. Is this like a 1 through 36 again, where it's not going to take forever, but these problems might take a little bit longer than some of your others. Okay. Now, example 2. Evaluate the following using the change of base rule. Folks, I am looking for a decimal answer. Do you know what log base 3 of 16 is off the top of your head?
Yeah.
No. Now, are there any properties from last week that would help us? I mean, 16 is 2 to the 4th, but does that help me with anything? No, because the base isn't going to be the same. Now, change of base rule. Yes, this requires the calculator. Okay? Because I am looking for a decimal answer. Can you just hit log of 16 on your calculator? No, because that's going to give me log base 10. Do I want log base 10? No. How can I do this? What can I rewrite this as?
Log is 16 divided by log of 3.
Okay. So one option is to say this is log of 16 divided by log of 3. What's the other option? Officially, if you look up at your rules, your other option is we could say what? Natural log of 16 divided by natural log of 3. Does it matter which button you use?
No.
No, just whichever button you use on top, you have to use the same button on bottom. You can't do a mix and match. And 3 decimal points. 3 decimal places. Sorry, that sounded weird.
No. 2.5 to, wait, hold on. You said 3 decimal places? 2.5 to the 4th. Oh, 2.524.
Now, all of that to say, do we agree with Brody?
I think I
Yeah.
I mean, unless I did it wrong too.
And are there ways to do it wrong? Yes.
I did log of 16 divided by log
Okay.
of 3. No, that's what I got. I just didn't. I just couldn't say 2.524.
Okay. You are supposed to be at 2.524. Now, I'm being lazy and I haven't put my calculator up on the screen. Did we all get that though?
Yeah.
We're all good? About the only way, so first of all, did you guys do a fraction bar? If you did a fraction bar, you can't really mess it up. The only way you could mess it up if you didn't do a fraction bar is if you did log of 16, didn't end your parentheses there and said divided by log of 3. Because it automatically pops up a parenthesis for you, doesn't it? If you do this, like so a horizontal statement, you have to make sure you end that. That's my only concern. Okay. Okay. Number 2. What are you guys doing on number 2?
Dividing.
Okay. What are you punching in your calculator?
Either log or natural log of 10 divided by either log or natural log of 6.
Okay.
Which would equal number 1.285.
Agree, disagree? Assuming someone would speak up if they are not getting this to cooperate. Okay. 3. Log base,
You can negative
1/2 of 2. What are we doing here?
Log or natural log of 2. I'm gonna say log or natural log divided by 1/2.
I'm lazy. I'm just going to say 0.5.
I don't know.
I mean, can you do 1/2 in there too? Yeah.
That's why
Okay.
I did that. Yeah.
So. Okay. What are we getting here? I heard -1 point, and I was like, what button did you hit wrong? And then you proceed with 0, 0, 0. So, okay. -1. Yes?
Okay.
Okay. So, now technically, I don't know if you guys, it's a tricky one to see. Technically, number 3, we could have used one of our properties from Friday. We could have made the 1/2 and the 2 be the same in terms of base. But that's not the directions. The directions are change of base rule. Okay? Okay. Since I'm not requiring you guys doing the homework, and we do have homework to check, and I'm keeping you guys busy in this chapter, we are going to skip example 3. Okay? It talks about how to, what it is it's connecting how to transform natural log of x, but based on a log-based something else graph. So we're going to skip it. Okay? I took off the homework problems, so don't feel like you need to, don't worry about it. We're skipping it. I'm just trying to get us through this chapter, and I rush. So your homework is page 283, 1 through 28. If you see me write 39 to 42 anywhere, well, that's because I forgot to take it off. That was the extra part. Okay? Homework is due when?
Tomorrow.
Tomorrow.
Oh my goodness. Are you wanting to see yesterday?